Okay, geometry, we're on to section 12.2. Again, the homework assignment for this section is right here. It's way at the back of your book. 2 through 30, the evens, and 36 through 40, the evens. Okay, so do that for Monday, and then we'll turn probably all your homework assignments in on Monday and go over questions and all that stuff. So 12.2 is talking about actually computing probabilities. So up here, like in 12.1, we were just talking about like counting options and like the number of ways that things could happen. And now we're going to actually be doing some computations and analyzing some things. So the first thing that we need to talk about is something called a union and an intersection. Okay. They will use the notation of like A being a certain event and B being a certain event, and union is like the U in between them. And they're talking about like the combination of all of those things happening together. So let me give you an example. Let's say we're rolling a dice, right? And a dice, the options or the sample space is 1, 2, 3, 4, 5, or 6. If we only roll one dice, that's the options that we have, okay? Let's say event A is the event that I roll a number that is greater than 3. Okay, think of numbers greater than 3. So numbers greater than 3 would be not 3 because it's not equal to 3, but greater than 3 would be 4, 5, 6. Okay, and then let's say event B is the event that we roll an even number, right? An even number. So that would be like 2 or 4 or 6, right? Now, the event that those two are happening together, greater than 3 and even, is the numbers 4 and 6, right? Those happen in both categories. That is happening all the way across. But A union B, the union just means everything happening together. If you see like this shaded region, like they have everything shaded versus over here they only have this guy shaded, okay? So in the union of those two events happening, we have the list. A union B would look like this. We would list all of the numbers in here, but only list them once. So the smallest number that occurs is 2, and then we have 4, and then we have 5, and then we have 6. So this list right here is the list of all of the numbers that are either greater than 3 or even, okay? Now, you heard me say that word, the word or, okay? Or is a union, okay? So when we're talking about a union, we're talking about either side, one or the other, or maybe both, whatever. But it doesn't matter which side you're on. We're gonna include you in the union, right? It's like union is like marrying all of the things together. So like when like a marriage union, you bring all of your stuff into the marriage, and sometimes you have 2 of the same DVD, whatever, but everything fits under one roof. That's a union, right? So this is all of your possessions all together after you're married, right? It's kind of a weird way of looking at it. Okay, don't think I'm stupid. But anyway, there you go. That's how you can remember it. A union is everything under the roof, okay? This one is something called an intersection, and I don't know. I think of this stupid because this is like a hill and you're intersecting at the top of the hill, like you're running into the intersection while you're driving your car at the top of the hill. So we're going to do the same thing. We're going to say A is the event that we have a number that's greater than 3 on a dice, which is 4, 5, and 6. And we're going to say B is the chances or the event that we roll an even number, which is 2, 4, and 6 on a dice, okay? And the intersection is only where they intersect each other, okay? Only what they have in common, which is 4 and 6. So if we do the intersection, we are doing the list of numbers that are only 4 and 6, okay? And that's what the intersection looks like. So union is everything under one roof. This one is only event A and event B happening at the same time, okay? And there's that word, and. And is only occurs when event A and event B, or the two events, happen at the same time. And that only occurs when we're dealing with the numbers 4 and 6, okay? So hopefully that makes sense. Example 1 is going to have us illustrate that a little bit. A spinner is divided into 8 equal sections that are numbered 1 through 8 as shown. Let event A be the event that a spinner lands on an even number. So event A is even numbers, which are 2, 4, 6, 8. If we have that spinner. Let event B be the event that it lands on a number between 5 and 8. And then they have this word which says inclusive, and that means including 5 and 8, right? So not just the numbers in between 5 and 8, which would only be 6 and 7, but they're saying including 5 and 8. Inclusive means 5 and 6 and 7 and 8, okay? And that's, I'm going to write it like this. I'm going to say 5 is less than or equal to x, which is less than or equal to 8. That's kind of how we say x, our numbers live between 5 and 8, including 5 and 8, okay? So then we have in this intersection the numbers, let's see, 6. Is that the only one that I have that cross? No, 6 and 8. But 6 and 8 are the two numbers that I have that are in the intersection, okay? So find the union. The union is all of the possessions. Everybody together gets to join under one roof, no matter what side of the list that they are on. And we're just going to list them in order. So 1 is not on my list, but 2 is, 3 is not, 4, and then 5, and then 6, and then 7, and then 8. So there is in my union. So the only numbers that are not are 1 and 3, I think. Okay. And then it says find the probability that event A or event B will occur. Okay, well, hold on just a second. Event A or event B will occur, or is that union, right? And in our union, we had 6 numbers, right? 6 out of the 8, right? So the probability that event A or event B will occur is 6 out of 8, which is 3/4. Okay, so when they're talking about probability, they're doing computations with the union or the or side, 6 out of 8 or 3/4. Okay. All right. Example 2. The Venn diagram shows the number of school sports teams who serve on a student council. One of the school teams or one of the students will be chosen at random to attend the meeting. Let A be the event that the student plays basketball and B be the event that the student plays tennis. Okay, now this is a little bit confusing because when we look at this, I usually ask, like, how many people are playing basketball? And people have told me before, 3. No, not really. The way that this Venn diagram is set up, there's actually 5 people playing basketball. So these 3 plus Meg and Ed, right? Those are all my basketball people. So there's 5 basketball people. Okay, now how many tennis people are there? There are 4. Meg, Ed, Kai, and Jamal, right? But then how many people are playing both basketball and tennis? Just Meg and Ed, right? There's 2 people that are in that intersection, right? Okay, so that's how this thing is set up, okay? Find A intersect B, right? This is like A and B. This makes like a little A, right? A and B together. So the only people that are in A and B together are Meg and Ed. So we list them out in our little curly Q brackets. And that's our intersection. What is the probability that the student chosen plays both basketball and tennis? Again, that's that and remember, and talks about the intersection. So how many people are in our intersection? 2 out of a total of, how many people are here? 1, 2, 3, 4, 5, 6, 7. 2 out of 7 is the probability that I choose somebody who plays basketball and tennis. Okay, 2 out of 7, and that's reduced. Okay. All right, last thing that they're going to talk about, I think, is something called a complement, okay? So a complement usually happens like when they say there's 5 yellow marbles and 2 red marbles and 6 green marbles and 4, let's say, blue marbles. Did I say that? 5 yellow, 2 red, 6 green, 4 blue. Okay, which makes a total of like 17 marbles. So they will say a lot of times, what's the chances that it is not red, right? Okay, so not red, rather than adding 5 plus 6 plus 4, right? Which is 15 out of 17, right? Rather than doing that, we just know that there's 17 marbles and 2 of them that are not red, so I would take 17 minus 2 to get 15, right? It probably gets me to the answer faster by subtracting that way and getting 15 out of 17. So either way you do it, you're going to get the right answer, but doing the complement is actually like subtracting it out. So you're taking that 17 or that whole number minus the probability of getting a red. And you're subtracting it out. That's something called the complement, okay? So Francesca bought 20 raffle tickets hoping to win a $100 gift card to her favorite clothing store. Now, the $100 gift card, that 100, that is a number in there that's thrown in to kind of throw you off, okay? Not every number or value in a story problem is important. We do have 20 raffle tickets, though. If a total of 300 raffle tickets were sold, what is the probability that she will not win? Okay, so if there's 300 tickets total, and 20 of them is how many is what her chances are of winning. She has a 20 out of 300 chance of winning, which means that there are 280 tickets that are not hers, right? So this is her chances of not winning, okay? But let's reduce. So let's divide everything by 10. Then we have 28 over 30, and I can divide that by 2, which becomes 14 over 15, I believe. And that's my chances that she will not win is 14 out of 15, okay? Pretty easy. Not too bad. Okay, last one is another one of those Venn diagrams. So outside a movie theater, 15 people were asked whether they had seen a comedy film or an action film. So there are 15 people total. Okay, now they filled out this Venn diagram different than I usually do. I usually put the total number of comedy here, and then I put 2 people are here that are comedy and action. But the way that they have this Venn diagram set up, just take note of this because this is the way that they'll probably do it on your homework assignment, is that the number of comedy people is actually 7 because it's these 2 groups together, right? So I usually fill out the Venn diagram that this is the total number, and then there's 2 of them here that are action, right? But they're going to say that it's 7 total, which means action, there are actually 4 people total that are action. Does that make sense? Like these 2 added together, right? Is the total number of action people. So there's that. All right. The Venn diagram shows the results of the survey. The value shows the number of people who gave each response. One person who took the survey will be chosen at random to win a free movie ticket. Okay. One person is chosen at random. Find the probability that the winner will be someone who saw a comedy film or an action film. Okay, comedy film or an action film. Okay, if I go back up to my cheat sheet up here, or means that I'm looking for the union of them, which means everybody in there together, right? Everybody in there together. Okay, so now here's the deal. When I look at this, I look at everybody together. So there's 5 people that are just comedy. There's 2 people that are comedy and action, and there's 2 people that are action. Just action, okay, which makes a total of, let's see, 9 people out of 15, and that's the probability that I get somebody that is comedy or action, 9 out of 15, which reduces to 3 out of 5, okay? Now, if you remember doing this from algebra, you're like, okay, wait a second, I thought we had to, like, subtract the number out in the middle, right? Okay, now you have to subtract the number out in the middle if, like, this number would be the total number 7, and this would be the total number 4. So let me show you how this works, okay? The chances of me getting somebody that's comedy is 7 out of 15 because there's 7 total comedy, right? I add that to 4 total action out of 15, but these 2 people are counted in both of these numbers, right? So I have to subtract 2 out of 15, right? And that ends up being 9 out of 15, which is 3/5, okay? So it just depends on the way that your Venn diagram is set up. If they're talking totals, you do have to subtract the person out of the middle when you're talking probability. But here, they're just saying, let me go back to this. They're just saying there's only 5 people that are comedy only, and then 2 more that are comedy and action, and then 2 that are only action. So we can just get away with adding those 3 numbers together to get 9 out of 15. Okay, I hope that wasn't so confusing. Oh, wait, let's talk about this guy right here. Who are these people? 6 down there. There's 9 out of 15 that are going to comedy and action, but there's 6 remaining that are not going to either of those, right? Maybe they're going to a horror film or something. I don't know. But there's 6 people that are not doing any of those, that are neither comedy nor action. Okay, so just so you know, that's kind of how that works. Okay. All right, so hopefully that made sense. Homework again is here, if you need to pause, and use the rest of the time in class to work on that, and you're good to go.